All right, guys, so today is day 2 of proving geometric relationships. Remember, we talked about different types of angles yesterday. We had these as options: VAT, we had LPP, and we also had RAT. Okay, so we have our vertical angles, our linear pairs, and our right angle theorems. Those were all new from yesterday. Okay, today is just combining more things, more terms. So our proof always starts with our given. So angle 1 and angle 2 are supplementary. I don't care if you abbreviate. Remember, they're your notes on a quiz or a test. I would want to see it written out. Okay, and angle 3 and angle 2 are supplementary. And we are trying to get to that angle 1 is congruent to angle 3. So remember, anytime there's a word in your given, you're thinking hopefully that you are going to define it. So definition of supplementary. So that would give me the measure of angle 1 plus the measure of angle 2. So I forgot my M. Measure of angle 2 equals 180. And it also gives me measure of angle 3 plus the measure of angle 2 equals 180. Okay, now remember, anytime that those things are equal to the same thing, that's when you use transitive property. It is not substitution. It would be substitution if I were plugging a number in for the measure of angle 1. I'm not plugging anything in. They're both equal to the same thing, so therefore we make a statement from what's left. So what's left is the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Here's my transitive property. Okay, then I'm going to get rid of the measure of angle 2, so I'm going to subtract it, SPO. So I have the measure of angle 1 equals the measure of angle 3. And I'm almost done because remember, this is what we're trying to get to. So this should be my last statement here. And think about how we went back and forth between our congruent signs and our equal signs. We're going to do that right here, definition of congruence. Okay, so there is proof 1. That was a lot like one you had on your worksheet yesterday. Okay, my second slide gives me a couple more things or ideas to work with. So this is the congruent supplements theorem that says if two angles are supplementary to the same angle or two congruent angles, then they are congruent. So if I look, I know that 1 and 3 are supplementary, 2 and 3 are supplementary, so therefore angle 1 is congruent to angle 2. Okay, so this is kind of like transitive, but it's different. Okay, this one, it specifically says two angles have to be supplementary to the same angle. So it's not a transitive property, but it is using that idea. Okay, so in this one, angle 1 and angle 2 would be congruent to each other. My second example, okay, over here to the right, I know my congruent angles, so I have 4 and 5 are supplementary, 7 and 6 are supplementary, and 4 and 7 are congruent. So I could really say that 4 and 6 are supplementary, okay, and then those would be shared. So 5 and 6 should be congruent. So angle 5 is congruent to angle 6. Okay, so that's my congruent supplements theorem. So I would abbreviate that when I'm writing it in my proofs, congruent sups. Okay. Similarly, we have our congruent complements theorem. So again, I would abbreviate that congruent comp. Okay, that says if two angles are complementary to the same angle or two congruent angles, then they are congruent. So my first one, 1 and 3 are complementary, 2 and 3 are complementary, So therefore, angle 1 is congruent to angle 2. Okay, and similarly, just like on the last one, 4 and 5 are complementary, 7 and 6 are complementary, and 4 and 7 are congruent. So that makes angle 5 congruent to angle 6. Okay, that's my congruent complements. Okay, so using that information, there's a new piece added. Okay, we are going to do another proof. So my first statement, remember, in any proof is always my given. So I'm going to write my given, measure of angle 3 equals 40. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Okay, so using my new theorems, the ones that we just talked about, this one talks about supplementary. So I'm going to switch back really quick and look at that. It says congruent supplements theorem. If they're supplementary to the same angle, they're congruent. So if I look at my statements, 1 and 2 are supplementary, 2 and 3 are supplementary. Okay, so what's shared between those is angle 2. Okay, so just like thinking, remember, it's like transitive, it's a different theorem, but it's like transitive. So we're going to make a statement out of what is left. Okay, so that's going to be the measure of angle 1 is congruent to the measure of angle 3. Okay, that is my congruent supplements theorem. Okay, now remember, once we've used part of our given, we're not going to use it again. So I'm looking at that other piece. The measure of angle 3 equals 40, and I'm trying to figure out what to do with that. Okay, I'm thinking maybe I'm going to plug it in somewhere, but remember, you can't have a plug-in or a substitution if one's congruent and one's equal. So I'm going to change this to say angle 1 equals, or measure of angle 1, excuse me, equals measure of angle 3. Okay, so that's my definition of congruence. Now I can take this 40, okay, and I'm thinking, okay, now I'm thinking maybe I can do substitution. So I'm going to look at these statements. Okay, and this is where a lot of you guys are struggling. You're like, is it substitution? Is it transitive? Okay, are they both equal to the same thing? That's what you really have to figure out. So if they're both equal to the same thing, it's transitive, which in this case, they are. They're both equal to the measure of angle 3. So this, instead of substitution, is going to be the transitive property. Both equal to the measure of angle 3. So the measure of angle 1 equals 40, which is exactly what we were trying to prove. Okay, last proof for today. Remember, every proof starts with our given. So RV bisects angle SRT, and angle 3 is congruent to angle 1. There's my given. Okay, anytime we have a word in our given, our next step is going to be a definition. So this time I'm going to define bisects. Okay, and I can use the numbers that are in my picture. So it says RV is bisecting RST. So which angles should be the same size? Remember, bisect's giving me 2 equal parts. So this is going to give me angle 1 is congruent to angle 2. Okay, those pieces right up top. Angle 1 and angle 2. Okay, so I used that part of my given. So now I'm looking at the other part of my given and my new statement. What do you see? What do you notice? Okay, so hopefully you see that both of them are congruent to the same thing, that measure, that angle 1. So I'm going to write a statement from what's left. So I have angle 3 is congruent to angle 2. And that, remember, is your transitive property. And that is what we were trying to prove. So that's a done proof. Okay, last slide. Complete the statements given that EHC, so these two together make up 90 degrees. Notice all of these are equal to 90, okay? So angle 5 plus angle 4 equals 90, okay? Then we have DHB, so DHB, so angle 3 plus angle 4 equals 90. And AHB, so this one right here is also a right angle, okay, 90 degrees. Okay, then I want you to decide how much these other angles are. These are separate problems, okay, so you're going to look at number 1 all by itself. Okay, so even if the same angle is repeated in the next problem, it's a separate problem. So number 1 says if the measure of angle 7 is 28, so I'm going to add that into my picture, 28. How much is the measure of angle 3? Okay, you might be looking at this and you're like, duh, Miss Sanders, I've got this one. Those are vertical angles, so that's going to be 28. Okay, so there's my first one. Remember, separate problems, so I'm going to take away that 28 because I'm going to solve for angle 7 in my next problem. So now I'm focused on number 2 that says if EHB, so this huge angle here, is 121, then the measure of angle 7 is what? So I'm trying to figure out what this is. Okay, remember that we have some information up here. So I know that 3 and 4 are both part of this problem. And I also know that 5 and 4 are both part of this problem. Okay, if I'm looking at that entire angle as a whole. So what I want to do is figure out which one is going to help me solve for 7. Now we just saw in the last problem that 7 is across from 3. So if I can figure out what 3 is in this problem, I can figure out what 7 is. So I want to take away 5 and 4. Okay, now 5 and 4 together we said make up 90 degrees. So I'm going to take away 90 from this problem. Okay, think about what's 121 minus 90. So you get 31 here for the measure of angle 3, which then makes this angle also 31. Okay, last problem. This one says if the measure of angle 3 is 34. So I'm going to erase what I have going on here because remember it's changing each time, different problems. Okay, so now I'm moving on to number 3. It says 3 is 34. How much is 5? Okay, so think about what could help us out here. So if 3 is 34, how do I get to the measure of angle 5? Okay, so that would help me get across from us. We would know 7 is 34. Okay, we also know that 3 and 4 should make a right angle. So if I think about that, back up here, we said 3 plus 4 is a right angle. So 34 plus angle 4 equals 90 degrees. So I'm going to take away my 34. And I'm going to do 90 minus 34 in order to get angle 4. So I have 56 for angle 4. And then I know up here that angle 5 plus angle 4, which we just said is 56, should equal 90. Well, think about this. Okay, you just subtracted 34 and you got 56. So now I'm subtracting 56, I should get 34. So this is also 34 degrees. Okay, remember guys, if you have any questions, please email me. I do get my emails while I'm gone, so email me or ask me questions when I get back. Good luck on your worksheet.